Hi, my name is Peter Claes, and today I want to cover an effect that I recently came across on the Side Effects website. It was done by Chris Harkin, and it is basically a curve being advected by volumes. It's a fun effect, and I thought I'd recreate it and also just show you the effect right now. So basically, what Chris did here, if we look at it, the curves are basically advecting by the volumes, by the velocity volumes, and he also has a lot of curves, and also they're quite nicely shaded, so there's a bit of that highlight, that specular highlight going on. So I want to talk a little bit about shading today as well. But overall, really nicely executed, really beautiful volume advected, custom velocity fields and things like that. Now I'm going to mainly focus on how to actually create this, but not so much on the velocity fields. I think maybe in a later tutorial we can cover the velocity fields. So let's dive into it and sort of have a look on how to do this, because advecting the field, or rather advecting the curve by the field, we first need to have a field. So let's dive into Houdini now. And over here, in order to do that, also let me modify the little viewport over here so we can see a little better. All right, so in order to do that, let's drop down a source. So I'm going to create a quick sphere, and from that sphere I'm going to start emitting some fluid. So from the Pyro effects shelf we can go to the fireball, right, with the sphere selected, and basically press enter, and it's going to create a basic fireball shelf template. So this is pretty straightforward. It is going to start emitting and it will continue exploding. Now we don't really care about the way that this looks, in the sense that I don't care about the heat field or the temperature field. What I'm really after here is the velocity field, because that velocity field is what we're going to use for the advection of our curves or our points. All right, so it's going pretty quick. Now notice that at the top it's kind of getting cut off. Also, one of the things with this sim is it is currently clamping to the initial bounding box, and those are kind of things that I kind of want to avoid, because I want to make sure that the velocity field continues going. Now eventually the smoke will dissipate and it will stop growing, but we'll deal with that when the time comes. So for now, let's dive inside and make a couple of changes. So here inside of the Pyro solver, inside of the resizing, I want to go to max bounds and turn off clamp to initialize. So that will basically allow the simulation to continue growing. The other thing that I might want to do is, as the simulation is growing, you can kind of see even here it hasn't reached the maximum bounding box, but it is growing faster than the bounding box can keep up with. So what we want to do is we want to add a little bit of upper padding. So maybe something like 3 to sort of give it a little bit more room to grow. And then let's rewind the sim and let's run it again. And now we can see that there is indeed enough sort of bounding happening here so that there isn't any clamping. And also the bounding box will continue to grow. Now that can be a good thing, can be a bad thing, depends a little bit on your camera. Now I'm going to let this grow, and basically as this is cached, we can then use the velocity fields in subs again to advect. So we have over here our original sphere geometry, then we have our Pyro sim, then we have the Pyro import. From the Pyro import, specifically the importing of the fields, as I mentioned before, here all the fields are getting imported. I don't really care about the color, nor the fuel, nor the heat, or the temperature, nor the rest. I don't care about those either, but the velocity and the density, we can kind of keep those. So when we do that, here we can kind of see, okay, great, my simulation is going, and it's all basically cached. If we middle click on it, we can see the density, velocity x, y, and z. So we don't really care about the density, do care about velocity x, y, and z. Maybe eventually we could do something with the density, but for right now, I want to emit some points and get them advected with this velocity field. So what I'm going to do is I'm going to create a circle, and this circle here, I'm going to hide everything else. I don't need to see everything else. This circle is going to be a polygon circle, so I have some points to work with. So let's have a quick look. So currently we have 12 points. I kind of want a lot more, so let's give it some more points. 50 should do. And then we can also resample, because this resample is going to give us a few options. First of all, it allows us here with the length parameter to control how much detail we want. We start with a pretty high resolution circle already, but then we can resample even more. The other thing that this eventually will allow me to do is add an attribute called curveu. Right, we're going to come back to that, curveu. That's basically to later on shade the circles or shade the curves. Currently it looks like a full polygon, but later on this is going to be just the curve. Next, I will require a DOP network. Also, maybe not a bad idea, save whilst we're doing this. So I've saved this under curve advect version 003. So this will be my emission, and then also I want the field. So the velocity field over here is going to go into the second input. Let's dive inside of our .NET now, and I want to make use of a pop object and a pop solver. So first, I'm going to drop down a pop object. I'm also going to need a pop solver. And let's wire them all up. And then finally, I want to emit into this, so I need a pop source. So with that, we now have our last pop source. Now, what do I want to do with my source? First of all, instead of scattering onto the surfaces, I simply want to use the geometry as is. The other thing I want to do is geometry source. I want to say, okay, go and use this from the first context. So the first context, where is that actually coming from? That is over here, the first context that is plugged into this first little input. We also have the second input over here, and we're going to use that in just a moment. So with that now, if we rewind the simulation, right, we can kind of see, okay, it emits a circle. Now, as I step forward, we can kind of see there are multiple circles that are basically being emitted on top of each other. I only want one circle for right now. So I'm going to say under birth, under impulse activation, I'm going to put an expression, $ff equals 1. So that means that the activation is only true for the first frame. If I step forward to the second frame, well, this is going to go to 0. And that means it currently won't emit in frame 2. It'll go to 0. So if we look at it now, it is actually simulating. It is only emitting one frame, right? The first frame. And it is over here, it's all cached. Now we haven't added any forces. So now I'm going to bring in the velocity force. And so an easy note to do that is the pop advect by volumes. Pop advect by volumes, there we go. And so this will allow me to say, okay, go and grab the velocity, a field, from somewhere. I want to grab that from the second context geometry. So second context, where is that coming from? Well, basically, if we rewind this for just a moment, I'm going to escape out of this. Then we can see over here, velocity x, y, and z is going to be plugged into the second input. All right, great. Okay, and let's now watch this as this gets advected. So there it goes. So basically it is being advected. Now it's going a little bit quick. I'm going to enable over here real-time playback so we can kind of sort of see it at a more real-time playback. I just went to wireframe so we can kind of see what's happening to the curve. Okay, so this is good in the sense that it is getting advected. The points are being advected by the velocity volume, but obviously they're kind of stretching. It's not really what we want yet. So in the same way that we have over here on the outside, the resample happening, right? I want that same resample happening on the inside. So let's go grab this resample, copy it, and I'm gonna dive inside here. So how do we attach this resample, that is a SOP operation, to this DOP network? Well, in order to do that, I'm going to make use of a SOP solver. So a SOP solver allows you to basically modify the geometry inside of your .NET, but you can make use of all the SOPs. So I'm diving inside of my SOP solver, and I'm going to drop down my resample node here. And for good measure, we're going to also add an output so that we can always grab the output of this network. So that way it's always going to update this. In the resample over here, I want to link the settings. We can already see in the viewport that there were a lot more points now. So this is going to happen every single substep, every single time this is cooked. So let's link up over here the length with the length on the outside so that we can kind of control our level of detail on the outside. So I'm copying over here copy this length parameter, and I'm going to dive back inside and hook that up on the inside to the length parameter of the resample on the inside. Now, let's rewind our network. We're inside of the SOP solver. I'm going to dive back up or jump back up so that we're outside, and now we can basically see the advection happening as it goes. And so we can kind of see that the curve is indeed creating all of the detail that we're after, which is great. This is looking cool. Let's have a quick look. Right, and so this is kind of our single polygon. Now notice we're currently doing that with a single flat circle. So what if we were to add a few more circles over here to basically give more interesting source rather than a flat circle? We're going to get to a whole bunch of circles. So in order to do that, I basically want to duplicate this circle. So I'm going to put in a duplicate, and maybe initially we can sort of test it with I don't know, 20 circles. and I want to give them a little bit of an offset. Now, if I simply say something like 1, right, then all of these circles are offset in time, in space. So I'm going to go and grab this parameter, copy the total number, and I'm going to say 1 divide by 1. Now, if you do something like this, 1 divide by 1, well, what does that do? It's just going to not do anything. The reason why I do the 1 divide by 1 is because this allows me to select that little one, just highlight it and then right click and say paste relative references, which is going to go grab that total number, paste relative reference, and it only replaces, over here, the 1. So now if we look at it, we can kind of see, okay, we have a whole bunch of circles sort of packed all in that 0 to 1 space. Now maybe I want to have them also go into the negative space, right? So we can say, okay, go 2 to 1, right? So 2 divided by, 0 by the 20 is going to go 0.1. And then let's offset them with a transform so they're nicely sitting around the origin, because right now they're not really sitting around the origin. There's the origin, and I basically just need to offset them in Z by -1. So when we've done this, right, we basically have all of our points now sitting here. Great. So all my points are here. Let's go inside of our DOP or see the result of our DOP simulation. This is going to simulate quite quickly because it's literally just doing point advection, and there we go. Right, so basically here we can see our entire smoke simulation doing what it's supposed to do. It's advecting all of these points, which is cool. But now what about these polygons? I kind of want to get rid of these polygons. So how do you get rid of these polygons? Well, instead what we can do is we can basically say go and unroll these ends. We can open up the curves using an ends operation and say open this. And so now I'm left with just the curves, right? So now if we look at it, basically here's all the curves, as it gets advected. All right, so that's kind of cool. We're up to, let's see how many points we have right now in the system, about 60,000 points. Okay, well, what else can we do with this? Well, we could say it's still kind of flat, right? We can basically rotate this around and duplicate our source even more. So here, after transforming, I'm going to append another transform, rotate this around, and merge this with the original system. So if we were to rotate this 90 degrees in the y-axis, and then merge this back in with the original source, then we are going to get this kind of cross-hatched, source. Now you can get creative with your source and you can kind of keep adding points and do different things with it. But now if we advect, right, we can kind of sort of see, okay, it goes out, it gets advected. We're getting all of this detail. All right, pretty cool. Now, lastly, what we can do is maybe make our source a little bit smaller, right? I mean, it does get advected here. We can kind of see something there. Maybe we can do something with that. We can kind of keep tweaking that so it doesn't sort of expand outwards too much. Or the other thing over here, what's currently happening is the velocity field is being used as a force. And instead, over here, if we set it to use it with the pop advect by volume, right, the velocity field, instead of update as force, I'm going to say update velocity. And so what that will do is that will override the velocity directly of the points. So instead of sort of doing another sort of integration, it is updating, almost directly setting the velocity. Now there is over here a velocity blend of 0.5, so that means that only half of the velocity is being used, but overall it tends to give you more accurate results, especially if you're just wanting exactly the look of the velocity simulation. So as you can kind of see now, it is getting advected again. And now the bottom portion is also getting sucked into this field. Okay, so it keeps sort of resimulating here the system. So I'm going to put a quick cache node in between. It should kind of do that already, but I just I don't want to keep resimulating the underlying fluid simulation because this one is kind of expensive to run, right? I mean, our fluid simulation, we can kind of say, okay, it looks like it is actually being saved, so that's fine. Let's have a look now. So how many points? We can kind of see we are dealing with a lot of points. So after a while, that's the thing with the system. We might need to sort of specify how many points do we actually want in this system. Right now we are up to about 500,000 points. So, a good amount, right? Maybe we can kind of modify it a little bit and say, okay, what if we set this to 0.05? So a little bit less points, right? But still enough to capture a lot of this detail. Oh, I believe actually I've done it the wrong way. It should have been the other way around. So here maybe 1.5. All right, so this is going to get a little bit less detailed, which is fine. I mean, we're still capturing so much of the detail. Great. So now let's have a quick look. Now we're up to, again, about 500,000 points. You know, it's starting to look kind of cool. We could kind of start thinking about what do we want this to look like when we render it? And also, what do we want to do with the color? So remember that curveu attribute that I had inside of my subsolver over here? I basically, under the resample, have curveu. That is an attribute that goes between 0 and 1. Now, when an attribute goes between 0 and 1, it is normalized, and so we can use that to drive a ramp. So let's bring it into this attribute swap over here with curveu. And I'm going to feed curveu into a rainbow. So a rainbow is a quite nice little tool to quickly visualize it. I'm feeding curveu into the U value of this rainbow ramp, in essence, and then we can shove that into the color. So now if we visualize this, we can, oh, well, you know, we have some nice colors over here that are basically starting out, as you can kind of see, using the curveu of each of these circles. And as it gets advected, you know, it basically keeps track of the curveu and keeps updating that. So now let's see if we can render this. All right, so in order to render this, I need a camera in my scene as well as maybe some lights. So let's create a camera over here. I'm gonna zoom out a little bit, you know, nicely kind of look at this. Let's maybe pick a frame, sure, frame 80 will do it. And then also let's add some lights to the scene. So I'm going to have a key light maybe over here, a spotlight, and let's make another one, a fill light on the other side. So here, this will be my fill light. And we can play with the illumination in just a moment. So this will be my key, and this will be my fill. And then maybe eventually a rim light as well if we need to. So the key light can be strong, and then over here maybe let's make that a little less strong. So something like a third of what the key light will be. Okay, let's look through our camera again, and I'm going to drop down a ROP net. So this will allow me to create a mantra node and start rendering. All right, so I've got my mantra node. Now, before we really start rendering, I also want to sort of specify, instead of Pyro import, I'm going to add the shader to a render node. So notice I'm making the connection here. That's gonna, you know, help us in a moment. So this is going to be render curve. Also, this is eventually the node that we actually want to render. I'm going to dive inside, drop down an object merge. Sometimes I will use a file swap as well and cache it out and bring it back in. But for now, since we're kind of working fairly quickly, I'm going to go and grab op input path of the incoming node. So of the parent node, go grab input 0 and then evaluate this expression. And also, I want to go and reference this. So I don't really have this out null yet. I'm going to go grab that one and create an out null here. So this is basically a hook that allows me to go and grab this result of this, of this simulation into my next node. So now we can hide everything. We can hide the source. I can hide the Pyro import if I want to. And here on the render curve, all I need to do is make sure that this evaluates. So I'm simply going to bypass and unbypass it. And that brings in all my details over here, 380,000 points. Now they are curves, so we basically get the in-between of the points for free. We don't have to interpolate any of these points because, I mean, we could if we really needed to. We can turn them into NURBS curves or stuff like that. But right now, let's say we're happy with this. So one more thing that I want to do before really kicking this off to render is maybe let's define the width of these curves. So I can put down an attribute wrangle, and width is one of those attributes that gets picked up by Mantra. So if we say at width, so f at width, float at width, equals something small, so something like 0.01. So this will give the width of the curve about, you know, a centimeter in width. Now notice the scene scale right over here, that's 5 meters, 10 meters, 15 meters. So this fireball explosion is pretty huge. So that means that the width of the curve is going to be nice and tight. It's going to be not very wide. Okay, so now that we have all of this, I'm going to dive back inside of my ROPNet. And we can basically start assigning our objects. So instead of rendering every object, I only want to force the objects I actually want to see. So under forced objects over here, I'm going to go and specify render curve. Now we can say render curve, or eventually we can do render star. And this picks up all the objects that we might want to render. Candidate lights, again, same deal. I only want to specify exactly the lights that I'm after. So in my case, my fill and my key light. Good. So let's try rendering this. Now we haven't assigned a material yet, so we might still have some issues with this. So I'm going to bring up a new floating panel over here. Let's bring this back in. And I'm going to go to rendering view here, Alt-9, and we only have one mantra up, so that's fine. So camera 1 is being used. There is only one camera in the scene. So we can kind of see how this is going to turn out. So, all right, there we go. Automatically already picks up the color value and it gives it some kind of material. Now I want to have a hair material assigned to this. So let's look a little closer, right? And maybe isolate. We can shift click on shift drag a bounding box over here and it'll just render this region. So also let's have a look at the alpha channel, right? We have kind of this kind of, nice alpha channel, but it's very noisy. So we have to do something to get rid of the noise. Specifically, let's, reduce that noise by increasing the amount of samples. Okay, so I'm going to turn off this render for just a moment. In the mantra rendering operations, pixel samples can go to 6 by 6 or even higher. That's generally good for fur or grass, and since we're dealing with curves, that's kind of what we're after. Now, the other thing that I want to do is I want to drop down a material network so that I can create a shader. So what kind of shader do I want to create? Well, we can go to the material palette and you can kind of see over here we have principled shader that's useful for all kinds of things, but the one I'm interested in is the hair shader. Now also this fireball shader, don't really care about that. I want to drop that shader into my object material net. Now why not into the material itself, into the context? Well, that's if ever I want to, I don't know, copy this setup to a different shot or something like that, then I can copy everything along. I don't have to dive into every single subnet and go copy it. So that's why I'm going to drop this into my object material 1. Okay, let's go back to my material 1. So here's my hair shader now, and now I want to assign this. Now, first of all, let's see, root color. Well, I have already nice colors, and we can tint with the point color or not. Let's not do that just for a second. I'm gonna set all my colors, my tip color and my root color here to 1. So if we wanted to assign this, we can basically just go to our object now, render curve, go to the render tab, go to material, and then here under that material network, we can basically assign that hair material. Okay, so I've assigned it now, and we can render it again. Now notice that these colors, CD, are just gonna be ignored by mantra. So let's bring up our render view again here, and I'm going to render this again. So, all right, in the color value, it should pretty much be somewhat white, right? Maybe gray because of the illumination, because of the light. And there we go, right? So now, the cool thing with this is because this is, this is going to give us quite nice detailed wispy detail. So my alpha channel, right over here is currently, fairly thin. We can also enable that into our beauty. So if we say, okay, pre-multiply that with the alpha, then we can kind of start to see what this actually starts to look like. Also, if we shift click away now, then it's going to render the entire image, and it's giving us, that really nice wispy cigarette-like smoke detail. So if ever you are asked to create this beautiful wispy detail, this is one way to do it. The other thing that I kind of want to point out is, currently it's kind of wispy, but that's also because, as in we can kind of still see the individual lines. But if we turn on a little bit of transparency, basically dial down the opacity, then we're going to see, a little bit more of it blending together. So let's have a look at that. So what I can do next is let's dive back into, or maybe I'll move this out of the way just for a second. I'll dive back into my material network and let's modify the opacity. So here under opacity, I'm going to modify the global opacity to something fairly low. I don't know, something like 0.05. We can try this for just a moment and render it. And so now what you're going to see is my alpha channel is going to be a lot less, and some of these individual curves that we could see before are going to be a lot less visible. So here were the curves before, right? So there they are, and now it's a lot less visible. So the alpha channel here, right, is very faint. So we could either have more, or we can say maybe this was a little bit too dark and just crank this up again. So 0.6. Maybe that's a little bit better, or even, let's see what else we have here, 0.5. So about half, half density. So, that's going to give us some kind of, values as well. Now, lastly, let's dive back into our shader and let's enable under the primary reflection to tint with the point color. So when we turn this on, we're basically bringing our point colors back into the system, right? Right. And so now we can kind of play with the width if we want it to be a little bit wider, so we have a little bit more, or we advect more points, more curves, things like that. But so this gives you that kind of nice whirly advected look. And in essence, you know, whether you need to do magical effects, you need to do maybe what Chris was doing with the advecting of the curves and make it into sort of a motion graphics piece. You know, you have different ways that you can go with this system. So with that, I basically wanted to, you know, this is kind of what I wanted to cover today, and I hope, you know, this was, you know, useful to you. If you like this kind of stuff, then please consider, you know, liking this video and subscribing to this channel. So with that, see you in the next video. Thank you. Bye.